Let me take the next question in the continuation, and which is the part of the section B. And while solving the section B, you have the internal choice also. Okay, so one by one, all the questions I'm going to take. Question number 86 says number of degenerate orbitals present in the third shell of helium ion is, right? So you're talking about third shell. He plus ion you're talking. Atomic number of helium is 2. It means you're talking about helium in the state when it has 1 electron only. So this is, yes, uni-electron system. Now in this case, they are asking that how many degenerate orbital are there in third shell. So as only 1 electron there, it means it would be there in the first shell only. Third shell would have all the orbitals which are degenerate. Clear? And third shell would have the orbitals, first specifically the subshell if we talk about 3s, 3p and 3d, right? And if I'm talking about, these are the subshells. Now turn for the orbitals. So it has 1 3s orbital, then 3 3p orbitals, and then 5 3d orbitals are there. Clear? Now what would be the sum of this? 1 3s orbital was there, 3 3p orbitals were there, 5 3d orbitals were there. Just add them up. All these are degenerate, because when we fill the electron, then only energy levels we decide, otherwise these are in degenerate state, right? So where the 9 is? Clearly you can see that 9 is given here in option 3. Done? Okay. Question number 87 we need to take. Statement question it is. Consider the following statements about the photoelectric effect. Okay. 3 statements are there. First says the number of electrons ejected is proportional to the frequency of the light. So the light that you are just allowing to irradiated on the metal surface is deciding the number of electrons ejected. Not at all. It depends on intensity, right? Further, so first statement is wrong. There is no time lag between the striking of the light beam and ejection of the electrons from the metal surface, right? As the light falls on the metal surface, electron starts ejecting. Clear? So the second statement is right. Okay. The kinetic energy of the ejected electrons increases with the increase of the frequency of the light used. This is also correctly said that whatever the kinetic energy, if you are just calculating, that is based on the frequency of the light used. H nu, right? So this is correct. Now statement B and C are correct, and this is given here in option 4 that you need to choose as your correct answer for this question. And if you have chosen, then definitely you will get the complete full marks for this question. Okay. Match the atom ion given in column 1 with the number of unpaired electrons given in column 2. Okay. So this is matrix match type of question where the two columns are given. In the column 1, we have the specific element or the ions you can say, and column 2 has the unpaired electrons. You need to match them up. Okay. So nitrogen, if you talk about atomic number 7 and the configuration is 1s2, 2s2, 2p, 3, and all 3 are unpaired. 3 electrons. So we can match it with this. Done. Chromium, 24 atomic number. And yes, the configuration I can write here, configuration of argon, then 4s1, 3d, 5, right? So in this case, total 6 unpaired electrons are there. For the chromium, I can match it with B. Now turn comes for manganese in 2+ oxidation state. So this can be written as argon 4s2 3d5 if it was manganese, but as it is Mn2+ ion, it means 4s0. So 5 unpaired electrons it has. Where the 5 electrons are given? Yes, it's here. So it's matched with C. Now the last is Fe in 2+ state. It means once again 2 electrons have been removed from the 4s orbital, right? So the configuration which comes out to be 3d6. It means among those 5 electrons in the d orbital, 1 get paired, right? So 4 is left. So this is D. Clearly matched. Now in which option it is given? That is the actual task to do. Okay. if you just check the option 2, have a look on the option 2, you will find here that in option 2 it is correctly matching. And yes, if it is so, you got the answer. And finally the marks as well. Now question number 89, the pair of compounds which does not follow the law of multiple proportions. What is law of multiple proportion? I hope you are aware that if two different elements are combining and they are forming two different compounds, right? And one element is there in the same proportion, then other element will also be there in both the compounds in a simple whole number ratio. So that I need to check CO2 and Cu, they are following. SO2, SO3, they are also following law of multiple proportion. Sulfur, one atom is there, 32, 32 is the proportion in both of them, and oxygen is 2:3, right? The ratio of the oxygen in both the compound, simple whole number ratio. Same ways, H2S and H2O, is it following? No. Hydrogen and sulfur in the first compound, hydrogen and oxygen in the second compound. That's wrong. In the first compound, two different elements. In the second compound, one element is different, hydrogen is same. So this is not following the law of multiple proportion. While if I'm talking about the fourth option, it is also following. So easy to choose this question. It's not going to take much of your time. Yes, easily you can choose the right answer. Okay. Now the turn for the 90th question. The quantum number which gives information about spatial orientation of orbital. They're not talking about electron. Clearly check in the question. Spatial orientation of orbital with respect to standard set of coordinate axis is. Clear? So this is correctly representing the magnetic orbital quantum number, right? And that magnetic orbital quantum number is given here in option 4. That's your answer. Easy question it was.